Good. Okay, hope you enjoyed this morning. My name is Alec Titterton. I am the CBM Development Manager for Computer-Based Maths. And let me introduce you to Krisjan Korjus, who's the project manager from the Estonian side that we've been working with recently on the Statistics Renewal Project. We're going to briefly run you through, we call it the anatomy of the CBM approach. Hopefully we'll show you what we've done with Estonia from both sides, from their side, from our side, how we've mingled the two cultures together and what we've come up with. We've just slightly changed what we're going to do. First of all, I'm just going to show you a little bit about where I'm coming from with what mechanics-centered teaching is about. My background is in education in England. I've taught for 15 years. I've done 5 years on a government contract supporting schools in enhancing their mathematics and computing enrichment and attainment. So I'm bringing quite a bit of educational background into the project. And so what I thought I'd start to do is bring a little bit of personal into why I am passionate about computer-based maths. So apologies for the small image, but I have 2 people at home, aged 10 and 12, who are going through the school that I was head of maths at 10 years ago. So I've got Millie on the right, Moss on the left. And I just thought I'd show you where we're at in the UK at the moment with maths education. Now, this is a good school, high attaining. I think my daughter's pretty good at maths. So she started off this year in September. She started doing some products of primes, doing some factorization like this. That was in September. On we go, and we have got, what's next? We've got a really hard example of some indices, manipulation with indices, negative indices, and she had to turn it upside down. Does she know why she's turning it upside down? That's a conversation I'm going to have with her at some point when I get back to the UK. We go on, the next couple of weeks, we've got some standard form, and she's getting them right, just little minute objectives. Let's pick another topic, just going through this book. We do some angles, some angle theory and triangles and parallel lines. What else have we got? We get on to more angles. Where's the one I particularly like? Oh yes, this is year 8. She's 12, so doing particularly well. Went straight from angles into right angle trigonometry, and has a method for doing it, which is written down here, that she has learned here. Let's see if we can show you that. Label the sides which have something written next to them. Great. Okay, where's the worksheet? She did pretty well at. Okay, I'll find that later. So, mechanics-centered, in my opinion, that's a very good demonstration of it. So the start of this project, Krisjan is going to talk about how we changed that approach and what we started with Estonia. Over to you, Krisjan.
Thanks. Yeah, hi again. Actually, my main presentation will be tomorrow, and then we will explain the Estonian side of the project. But I was actually working for this first phase of inventing the curriculum in England, in Wolfram's office. There were 5 of us, and we were working 2 months full-time. And our aim was to build a new curriculum based on all the ideas that you have heard so far. It was extremely complicated. We failed all the time, things didn't work out, and so on. So I will give some of my memories of it. So we were building a curriculum based on these ideas that you have heard, and it was for statistics and probability theory. So how did we start? As you usually do, you think of, we wanted to teach something in statistics and probability that would be very useful for students. Luckily, Konrad Wolfram was very keen or very powerful in saying that we shouldn't care at all what's done so far. We can do whatever we want, absolutely whatever we want. We can forget everything that's done so far. So we tried it. We still started with something simple. Like we thought that, oh, maybe distribution fitting will be useful. Then we started thinking about real life examples where would distribution fitting would be useful. We were trying to invent different stories, different real life problems, and we failed miserably. We just spent like 4 days, 5 of us, inventing nothing. Everything was pseudo context, meaningless exercises, didn't make any sense. So what to do next? It's just so complicated to start from the mathematical idea and then inventing something around it. You are creating something that doesn't make sense. You cannot start from this purple box. It just doesn't make sense. So the next idea was to, okay, let's forget all the statistical ideas. Let's start inventing just problems that we like. We like mathematics, we like science, we like to know stuff. We were just inventing different questions to solve. And this was rather successful. We invented many, many things. Should I take a train or plane? Which is more dangerous, smoking or drinking? Like, when will I die? Should I insure my laptop? Should I take the risky pension fund or non-risky fund? What does it even mean that it's risky? So on. We were inventing these different storylines. And these questions, they kind of made sense. And it was good. But then we started like kind of building something around it. And again, we kind of ruined everything that we had done so far. We started thinking, oh, this would be the nice place to teach histograms. Oh, this is a nice place to teach probability distributions. As soon as we started thinking about teaching, learning, things went wrong. Again, we were far off from the real world. So another useful hint, first hint was don't think about statistics. Second one, don't think about teaching or learning. Just invent the storylines. But so how did you do it then? And the solution was that we solved the problems ourselves. And it was as simple as that. For us, it took sometimes only like 5 minutes to solve them, sometimes a couple of hours. But we stopped thinking about teaching or learning. We just solved the problems ourselves. And it was brilliant. Now all the storylines made sense, a lot of sense. Everything was like correct. And that's it. But then there was a problem that lots of these issues that we solved, the problems that we solved, most of them they didn't make sense in some other sense. We couldn't now teach or study them or use them in high school. The problem was that some of them were too easy. Quite often it was just to go to Google and get the answer. Some of them were too complicated. For example, we wanted to know how many people would come to my birthday party. If I would invite 80 people, there would be 1 week left. 20 of them have said no, 10 of them have said maybe, 10 of them have said yes, they are coming, and 60 of them haven't answered. How many of them will turn up in a week's time? It turned out that we don't use statistics nor mathematics for it. It just doesn't make sense to use it. The model that we built was so hugely complicated, didn't make any sense, so we dropped it. And in the end, I think we invented about 100 different stories or problems to solve, and only 20 of them were usable. 20 of them made sense in high school context. Then now another problem that we faced was that we are kind of going through the problems, but we are kind of getting too far from the statistics and mathematics. And how can we be sure that if we are using some kind of distribution fitting or some kind of test, how can we be sure that the students can apply the same things in other contexts? Maybe they now can only solve this one particular problem, but they cannot understand that there was something more abstract. Our first idea was to make a like kind of traditional lesson in the end of one problem. Like 3 problems, you're solving something, like are girls better at math than boys? You're solving it for 3 days, and then you will abstract out this hypothesis testing. But again, for some reason, it didn't make sense. Why do you start doing this old school mathematics again if you were doing something interesting before? And then we invented something that we call primers, but maybe it's better to say theory files or theoretical files. Every time when we are using some kind of word, like probability distribution or distribution fitting, a student can click on it, and then there will be an abstract, like short description of this, what does it mean? Probability fitting, hypothesis testing, and so on. It's kind of like built-in mini Wikipedia. And it turned out that it makes sense. We are doing it in the real world. If we are solving something, we are going to Wikipedia if we don't know anything or something. Now Alec will soon show all the curriculum and all the materials that were created after the curriculum. And tomorrow I will explain what teachers are thinking about it, what students are thinking about it, what are issues in implementing it, and so on, because it's complicated. But to sum up, if anyone wants to do something like this, build a statistics or math curriculum, then I would advise to do this. First, do not think about teaching or learning. Think about actual problems. Start from real life. Again, not from abstract concept. If you have the problem, then solve it yourself. Again, don't think about teaching or learning. As a result, only 20% of these things that you have invented make sense in and to do it in high school. But it's good. It was still most efficient method that we invented in these 2 months. And to solve these problems that they wouldn't be only particular problems, that they would be able to generalize, add the generalized stuff as in real world. Mimic the Wikipedia use. Create your own theory files that they can read themselves if they need something. I think that's it, and Alec will show now what we actually invented. What are the curriculum topics and what are the materials? Thank you.
So Krisjan had the great bit where he wasn't thinking about teaching and learning. I come into the contract. I have to think about teaching and learning. So let's see what we actually did. Okay, so let's make sure we can advance. The problems they came up with, as Conrad often says, they have hair. And what he means is, if you like the metaphor, they're not always neat and tidy. You get all sorts of colors, shades, styles. Hair has many layers for some people. And you need a cycle of treatments to sort them out. Sometimes you just got to do something once. Sometimes you've got to go around and look after it a few times. And then when you think you've got an answer that you go out with your best solution for your hair, some people might go, no, that's not right. That's not looking very good. Go back and have another go. So I like that little metaphor. My basis, as I said, was in education in England. And before I started padding out the curriculum with materials, I wanted to keep these guys in the forefront of my perspective when I was authoring with the other Estonians. So we've got Ben, Sam, Emily, Polly, others. These are my year 11 class last year, age 15, age 16. This is a lesson where we'd just done surface area of a cone. Well, that was my plan. You can see they wanted to go their own way with it. So eventually we just turned it into what's the biggest cone you can make out of a piece of A4, and they problem solved around that, which I thought was a very nice way for them to take it because I hadn't planned that. So I've got them in my forefront when I'm padding out the curriculum. So the storylines that I walked into after Krisjan and the guys had written the curriculum were a set of what we now call modules. So if I bring the modules up and show you what they look like, and let's see if we can get the welcome screen up. There. Okay. So this is what we produced. It's a little bit small. We've got 6 modules aimed at the lower age group, which is ages 13 to 15, and then the second group of modules aged 15 to 18. Some of them are repeated. And the lesson titles are like, Am I Normal? As Krisjan said, we've got Should I Insure My Laptop? We've got Proof by Survey, Are Girls Better at Maths? How Can I Convince You? Causal Correlation, How Many Words Do I Understand? And How Tall is the Tallest Woman? And you can see these on the pods upstairs in the booth. We've got all the modules on there if you want a closer look at them. So I'm just going to take you into Will It Rain Tomorrow, which is an upper age group module. What you're looking at is what the students will see. If they log into their class, they've got a palette where they can see how they are doing in the storyline. They've got a number of lessons. We've got 4 lessons in this one, and we've got a number of activities in each one. There's an introductory text in there. Let me just make it a little bit bigger for you. And I will, let's see, that's that, not much better. Okay, so there's an introductory text for the students before they go in. And let me just take you through the first lesson, which has got 6 activities. There's an introduction, a little video about big data. Yeah, we're already in presentation, I think. Let me go full screen and make it even bigger. Let's see if I can make it bigger. How's that? Let's, no. I'm on 150 at the moment on my screen. Yeah. Okay. Right, let me just get my mouse back on to where we're at. And up there. Okay, let's go over there. Okay. Second activity, I don't want to go into all the text. I want to give you a quick flavor of what you're going to see if you're a student. There is a lot of material that you're not seeing as a student that is ingrained for the teachers to use. So the first lesson is about finding out data, what the data is about, to do with weather. And then we go into an activity where they can pull up the data for their own particular town in Estonia, so they can click on a weather station in Estonia, and up comes the data for the last 3 years. And they can start talking about chance of rain. As you can see, we've got questions built into the materials. They can answer questions. They can send their answers to the teacher, and the teacher can see responses. They can do various demos. Let's move just quickly through these. I'll be doing a full demo of a lesson tomorrow. I don't want to spend all the time on it now. Okay, there's more questions. And what we've got here is a change in the definition of what precipitation is. And if precipitation goes up, the amount of rain, is that precipitation or is it rain? And the probabilities then can be changed, and the students can talk about what they're doing. As I'll show you in a bit of how the teacher would control this and what they will be doing. It's not all about students sitting one-on-one with the computer, just talking to the computer and typing in answers. Let's go through to lesson 2. Lesson 2's got a brainstorm. It's then going into looking at what factors affect the chance of rain. With various demos, they can investigate conditions on the probability. We've got primers built in, as Krisjan said. This one is on conditional probability. So this is this sort of like Wikipedia built in, so the students can click on it and read a little bit more about the definition of conditional probability. Come on through. And we go down into drilling down into individual dates, whether that condition makes a difference to the probability of it raining tomorrow. Lesson 3 is where they actually try and answer the question, will it rain tomorrow, using the tools that they've seen so far. And this tool takes a little while. And they can condition the data from various choices, whether it's humid, maximum temperature, the month, and the days. And they can write a little report about whether they think it will rain tomorrow based on the conditions they've chosen. The good thing about CBM, the idea is that they take those skills and then research a project on their own. So the fourth lesson is a distance from the third, where they've been away and they've researched a little project using the tools we've given them. This one, hopefully, we thought maybe students throwing paper into a bin. If they succeed the first time, does it make the probability of them succeeding the second time change? So that is a little research project they would do, or they could choose their own in the fourth lesson, and then present their findings in the small groups they're working with at the end before they do a summary of the module. Now that is far too quick, me going through of the student materials, but I'm just showing you a quick taster of what it may look like to a student. Okay, so let me just pull that back tomorrow. Okay. So, problem-centered, that was conditional probability. They're experiencing the maths. They go into depth and complexity necessary, and they relate the language of the maths to the meaning of the content. The bad side is, as we've just heard earlier in the morning, the assessment of that is not too easy. And the debate following this session hopefully might pull out some more issues to do with that. The mechanics-centered is where we're at the moment, and we're hopefully going to get away from that. The maths is introduced when it's needed. If there is more input needed, like the Wikipedia pages, then we've got the primers to support the maths as we go through the storyline. So what do you do in the classroom? How does the teacher behave with the students? What structures can we put in? We had to think carefully about that. And we want to keep everything that is good about traditional maths at the moment, the teaching styles, the interactive discussions, using group work, getting the students involved, and then add to it with the computation ability that we can put into the materials using what you've just seen. So, drawing on my background, I started teaching in 1992. I was involved in a maths enhancement project which was based on a piece of research called the Castle Project in 15 countries. That pulled out good teaching from Finland, Hungary, Poland, a number of countries internationally. And that was where I started learning about curriculum reform in terms of maths. The Maths Enhancement Project, all the materials are free, they're all online. Have a little Google it, and everything you ever need is there. What they did well, and what I've pulled out, is going into concepts into depth, staying on concept, staying in one particular area, not jumping around. Keeping everybody together, having the whole class progress together. Making sure teachers know how to communicate properly in mathematical terms. Using the students more, not just listening, but the students lead, and using misconceptions, and implementing a full scheme of work. I also pulled from this piece of material from Malcolm Swan in the University of Nottingham in England, Improving Learning in Maths, a really basic piece of material for maths teachers, taking them from didactic teaching into traditional plus, I would call it, where there's much more interaction between students. Things like card sorts, matchings, visuals, posters, analysing reasoning through visual images, that sort of thing. Pulled from that. A I suppose quite a few of you heard of Kagan, Dr. Spencer Kagan, and cooperative learning and the structures for increasing communication between students. I've taught maths in a Kagan style using a number of those. I think they work, I think they're good. We've tried to include quite a few of them into the materials. And also Joe Bowler's complex instruction, similar to Kagan, giving groups roles within the groups, keeping mixed ability, keeping everybody moving together, and responsibility for learning within the group. The last one, which I'm pulling from, this isn't from my direct experience, but something I learned about as I was doing my traveling around for various schools. The Maths in Context curriculum, which came out of the Freudenthal Institute, it's making its way into the UK as making sense of maths. Realistic, not meaning real world, but realistic meaning problems that the students can imagine. So that's where our narrative comes in, and the problems that Krisjan was talking about, that some of them don't work. You need narrative storylines that the students can relate to, and that can actually conceptualize visually. So, then I pulled from my knowledge of computer-assisted and what the good bits are of it. So this is where the technology of the advancements that have been made recently really start to show. Now I'm going to show you this. See if you think this is a good computer-assisted or a bad computer-assisted. It's going to come on the screen in a second when it starts playing. So is this good? Okay, you get the idea. Is that good use of computer?
Excellent. Good for who?
Good for who? I was quite wowed by that when I first saw it. I'm now on the border. I think it's good for motivation. Change is always good for students. They like playing with gimmicks. I'm not sure that the maths was right. And I'm not sure using PSP for it is the right idea. Then looked at what else is available online. Lots of content management systems. Now, this one is a UK one. Obviously, there are a vast array of online learning portals where the computer can track, can assess, can deliver content to the student. So some of that, yes, we need some of that. And also we need things online where the students can demo things online. This one is particularly from a GeoGebra example. And they can manipulate online using tools like that. So there are a number of aspects from computer-assisted that we wanted to include into the materials for computer-based maths. Okay. So, what does it look like for a teacher? This was the design brief that I sketched out with Conrad and the guys. On the top level, we've got the module, which is a storyline. Then at this level, we've got lessons, a number of lessons within the module going through the story. Within the lesson, we have activities coming down, and within an activity, which may be 5-10 minutes, maybe up to 20 minutes, then we've got what we call modalities. Now, modalities are the learning structures. There isn't a phase in the lesson where there isn't a structure. It may not be mathematical content, but there must be a structure that is in place for those few minutes, right through the lesson. Every single part of the lesson must have a structure. There isn't, oh, just go and think about it and do this. It's a structure. It will be a discussion. It will be a brainstorm. It will be something. Every part is itemized for the teacher. So what does it look like when you do that? Hopefully this won't be so small, and we might be able to see a bit better. Okay. Let's make this one much bigger. Okay. How's that at the back? Yeah? Okay. So, top-level overview, lesson plan. Lesson plan may look like this, which is designed to be a printout of the scheme of running the lesson. Let me just pull that over. Okay, so will it rain tomorrow? You get an introduction. You then get these structures, these modalities I was talking about. Just the objective, the name of the modality, who's leading it, what sort of group size it's going to, and how long you expect to last that on that modality. Next activity. Again, we've got modalities, who's leading it, is it the computer, is it the teacher, is it the student? And there's a mixture and blended approach to the lesson. So you can see the modality names, and I'll go through a few of them, what they mean in a second. But the whole lesson then runs on that basis. Okay, so let's go to that one. So the overview at the beginning gives you the activity titles. The idea is that the teacher will prepare beforehand using the full version. There's a button there called Teacher Prep. They will prepare before the lesson rather than doing it in the lesson, but we've got contingency plans in case they haven't as well. Okay, so, and then this is what it would look like within the materials for a teacher. So let's look at the beginning. So the way we've built it is anything in blue will be guidance for the teacher, and it won't be seen by the students. So the material I showed you earlier had no blue in it. It was just for the students. You've got activity titles, you've got aims for the activities, and then you've got these modalities that come in across the screen. So the first modality you can see on this one is called a discussion led by expert. Led by the teacher, the whole class for 5 minutes. The objective's on the screen there. And then what we've done is put in, let me just make this a little bit wider to see the whole thing. Okay. Scroll over. Okay. Sorry, I'll just get it on the screen. It's just gone off screen because it's so big. Okay. Sorry, I'm just trying to see the first tab, which is steps. Okay. That's what the teacher should be doing. And if they're not sure what actually they should be saying, then we've got a tab for actually to say, this is what you should say. And we've also got some answers, if there are answers that are needed there. Okay. As we go down, we've got material for the teacher. So the student would see the first photograph and discuss what is normal. The teacher would then be able to throw something into the mix to add to the discussion. And I need to get it on screen. Okay, so we've got this functionality where we can select any cell and throw it to the full screen. Now that will probably throw it somewhere else. It's up there, okay. And so any part of the material we can throw full screen and discuss it with the students. And we can throw multiple versions and throw whatever we like to make it bigger. Okay. Down here we've got quiz questions. Now the teacher will be able to see the responses. If everybody's logged in online, then the teacher will be able to hit response and refresh and get the responses from the class. There is nobody in this class at the moment, so their responses aren't coming up. And then we've got other things down here, other materials to aid the discussion in that modality as we go through. So there's a huge amount of material in the teacher's version, extra on top of what the students see to make the flow of the lesson, to keep the interactions going, to keep discussions going, and to aid the communication between students. Okay, I'm running out of time, so I'm just going to flick to some of the modalities that we have and show you some of them. Okay, so what we want to do is try and get away from the traditional maths teaching, get the best of it, bring the best of it into the CBM style. That's not meaning we throw everything out, we just try and add to it, make it better. So we've got brainstorm, where students and teachers can brainstorm and start adding things in and do that. All those answers that they type in will all be sent to the teacher. The teacher can then create a much better discussion, seeing all the answers come in live. We've got sorting, classifying, and ordering. Now, that is a very nice activity that comes out of improving learning in maths. You've got card sorts, that is really good activities to do in maths lessons. How do you do that in a CBM classroom? Well, you could do it by doing physical card sorts, or you could also do it by doing this, where you can drag various statements into various boxes, and whichever one you think where they go, then instead of the teacher having to come around and check physically, then you can just do that, and you'll see which ones are in the right place, which ones are in the wrong place, whether they are quantitative, continuous, whatever the options are. So drag and drop is what we call that, a version of the card sort activity, but done virtually. Peer review. Now, when you're all online, all the students can peer review each other. The teacher can control who gets whose paper. So we can add how many students see how many different papers and decide for the students. We don't have to spend lots of time saying, no, you go to there, you go to there. It increases the pace of learning, get everybody equal. Great for group learning. Okay, what else have we got? We've got find the error, traditionally done with papers being handed around the classroom. Now we can do it by giving them a statement, giving them a manipulative that they can work with and see if they can find the error in the statement and see what happens. So we can do it electronically now and then send the answer back to the teacher. What else? Round table. Round table. Where's my piece of paper gone? I've done this where students write an idea on one piece of paper, they fold it over, they give it to the next group, like that, doing that physically. In CBM, we can do that by having all students who register send an idea, it gets sent to the next student, it gets sent to the next student, and they can talk about the ideas that way. And just a few more in the last one. Find someone who is a Kagan structure, great for getting students talking. We can do that equally as well electronically and getting them moving around the room at the same time. Word cloud isn't one I think you can do traditionally. I don't think you can create a word cloud where the frequency of the words depend on their size. I don't think you can do that. We can do that in CBM. We have the technology. And create a question. Obviously, students can type in questions, they can make lists, they can send them to the teacher can see. Quiz questions, we do lots of quiz questions, lots of multiple choice, lots of free form responses. And finally, discussion, connecting ideas, forming opinions. Actually, no, there's one more. The most important one, I think, manipulating to discover. Now, that can be done in traditional classrooms using some approaches like, we mentioned geometry earlier. So you can put physical things together and manipulate them to discover different facts, different concepts. You can find the angle theories of circle doing physical things. You can add to that with CBM because we can do it all and electronically as well, as you've seen some of the examples already. Okay, very quick run through of how we've done the Estonian project and some of the things we've implemented. If you would like to experience one of the lessons, not the one I've shown you there, I'll be running 2 sessions tomorrow. You'll need to be logged in, you need the materials that Michael talked about. And that is the end of my little introduction. Thank you.